Introduced our speaker, Dave Hatch, who was the GPS IIIF Program Management Director and Navigation Systems Message Area Deputy for Lockheed Martin Space, located about an hour south of us down the Front Range. Dave is, as I just introduced his long title, he's responsible to deliver the follow-on GPS GPS 3 space vehicles on time and, most importantly, within budget. The program has 7 vehicles on contract, with more to be awarded at the end of the year. Prior to this role, he was chief engineer in Navigation Systems Mission in the Navigation Systems Mission area, for which he was responsible to ensure the technical quality of navigation systems product and lead the evolution of future position navigation and timing mission solutions. He's been at Lockheed since 2003, which is as long as I've been at UNAVCO, coincidentally, and working on controls and sensing, and analyst and hardware engineer on the airborne laser program. In 2012, he transferred to Denver to support special programs line of business, where the highlight for him was managing the design, build, and flight test of 2 demonstration payloads in less than 10 months. Dave has a bachelor's degree in applied science, applied physics from University of Utah, and a master's in computer science systems engineering from the University of Denver. And he will bring us up to speed on GPS modernization and how the GPS IIIF constellation will make our lives better. So take it away, Dave.
All right, thank you. It's a pleasure to be here. Like you said, I'm the GPS IIIF program manager. And I get the joy of striving every day to deliver the next generation GPS satellites, the 3rd generation. So we've launched, 5 vehicles already on this constellation GPS 3, and we're almost finishing up the 9th and 10th one. So I'm going to walk through this a little bit, and I'll just jump into it. All right, let me get my cursor in the right spot. All right, so there isn't a day that goes by that each one of us doesn't use GPS or benefit from its far-reaching effects on the world we live in, from maps on our phones to financial transactions, to making so many things we do smarter and thus more efficient. But GPS has also become a significant backbone to the US military, providing accuracy, precision, and safety to everyone wearing a uniform. It's part of our critical national infrastructure and vital to the US economy, public safety, and national security. Our systems provide worldwide, resilient, always on position navigation and timing infrastructure. And we like to say, if we glitch, the world takes notice. We are proud to report, like I said, 5 of the 10 GPS 3 satellites are on orbit. And we have 1 that has been called up, and we are processing it towards a launch date early next year. And then we will launch 7 through 10 over the next few years. Our follow-on production is underway, with hardware being built and delivered to our high bay across the United States. And with our first Pathfinder vehicle, that's going to be assembled this year. And then like was shared, we have vehicles 11 through 17 that are on contract. So that makes the total 3 constellation at 17 right now. And we're likely to get another order in October for 2 or 3 more satellites. So what does that mean to all of us? So what does the GPS 3 follow-on production bring as opposed to GPS 3? So first, it brings 60 times more anti-jam capability than the legacy GPS system through the use of a regional military protection mode. Some may have heard about it, spot beam or RMP, we like to affectionately call it. but it's a large reflector that you can see on the chart that sits off the side that focuses M code into a targeted area on the Earth to bring greater power to the fight in a specific area. We also added a laser retroreflector array, we call it LRA, that will increase the accuracy of the measured satellite where it is in absolute position, and thus brings us even more accurate and precise PNT to the world. The government partnered with our international allies in Canada to add a search and rescue payload that locates beacons from Earth to send help to those in need in any part of the world. We actually have a member of our team that was scuba diving and was lost and pulled his beacon and was rescued when the boat left him out in the middle of the ocean. So we have a little bit of familiarity with the benefit of SAR. We enhanced our mission capability by evolving to the modernized LM2100 combat bus. You can see in the bottom left hand of the PowerPoint charts. And what this really does is it increases our size, weight, and power capability and enables late integration of hosted payloads with the ability to add a third major mission payload if we upgraded our power subsystem. So it gives us the real estate that we could add more mission or late mission as the threats evolve or the needs evolve for the civil users. I think, to quote our customer when we first got our authorization to proceed, our ATP on the contract, they said, "We assume vehicle 11 or vehicle number 32 will not look like vehicle 11 because they have the option of ordering up to 22 vehicles on the 3F program." So we wanted to make sure we had the space and the ease of ability to integrate anything in the future. Our current focus for GPS 3F is mission evolution. And it's really in two areas: enhanced warfighting effects to the mission and the flexibility needed to deliver a more hardened PNT to the fight. Really, our mission, we like to say, it's one of our mottos in the program. Our mission is to bring PNT to the warfighter and to the world, both the military and the civil users. So MEO itself is kind of a challenging orbit. It's a little bit unique. I think there's more people thinking about MEO in the last 5-10 years, but it's also a great opportunity to enhance our space superiority. So GPS has become very familiar with multiple decades of operation in MEO on how to best to function effectively in this unique orbit. And so what types of hosted payloads, like I said previously, could really hitch a ride on what we call the freight train to space at MEO? The unique requirements of GPS and our partner missions allow a real wide variety of RF and optical payloads. The government put the call out to industry and academia and other government agencies to what's called, they affectionately call it swap meet. The pun is intended to understand how much interest was out there for folks that might want to host on vehicles 9 and 10. So GPS 9 and 10. And this is a totally new way to look at maximizing capability to space. So, we build these satellites and we have to make sure they last, in this case, for 15 years, right? That's our mission life requirement. So that means we have more power because they degrade over time. So what this allows us to is to say, hey, let's put folks, insert them onto the platform, allow them to do test or maybe some experiments, or maybe even some operational capability up to the time that maybe we wouldn't have enough power as the power degrades. But it allows us to use every inch, watt, and pound of our consistent production line. We've been putting out satellites consistently on GPS 3 and the 3F follow-on. We're just jumping right in as we finish up 10. We're starting our Pathfinder vehicle, like I said, this summer. So what the government's doing, they're currently evaluating the pre-screened potential payloads, and they've actually determined some priorities, and we're working with them to figure out which ones would bring the best capability or maybe accelerate the speed of technology. And it also gives opportunity for new entrants that maybe they don't build the whole satellite, right? But they have a cool payload or a widget or something that they want to prove out and get to that higher technology readiness level and fly something in space. So we think this is a really cool thing that the government is leaning in on, and I want to give them a lot of credit for this because we think it's a smart way. There's the small satellites to try to proliferate, right? But why not use all the space on the more large class satellites like we have on GPS 3 and 3F? So integrating hardware into space platforms, right, can sometimes be complex, and it involves a lot of interdependencies. So in order to simplify that capability, we're also looking at making it lower cost with higher speed at a similar risk. We're looking into investments in a modular open systems approach and to help simplify that integration. So we did a little bit of work to move all the boxes more to the center so it's easier to access on our combat bus. And we also stubbed out a specific area for our hardware so that if we add another payload, we can plug it in a much more simplified manner. But what we're really looking at doing is creating much more of like a USB port into a satellite. That's kind of the government and Lockheed's vision and goal. So Lockheed has specifically invested, you see it in the bottom right, is a way to get to modular open systems approach. It's not specifically what it is, but we call it Aspen. And this is an ability that you can connect pre-launch or actually after launch with, if you have the right interface, you can connect and have power, telemetry and commanding, as well as high-speed data interfaces. So we just released the physical interface. It's out in the public now that people can look at and design to. There's a medium-sized one that's about this big, and then there's a small one that's more for a CubeSat level. So this is something that we haven't quite inserted into our baseline on GPS, but we're looking to do that for our LM2100, our combat bus, our line, so that in the future we can add capability, enhance the capability on orbit, or allow us to add late hosted payloads that could, separate or have their own mission or share with the ride, depending on what somebody brings that would connect to this port. So it has all the electrical side as well as the mechanical side to make it much easier to dock pre and post launch, which we really think is a game changer. Let's see if I go to the next slide. So as well as having the awesome opportunity to have this high production rate for a large class satellite, I know those of you that build like electrical cards and things like that, you're like, 22 vehicles? That's not huge production, but in large satellite class world and not LEO, it's a pretty large production line. So we're jumping all in our digital transformation. It is in full swing in what we call our GPS processing facility, the GPF. That's the physical building that we use to build these satellites. Advanced manufacturing techniques have been demonstrated for mechanical, electrical, and data processing at the space vehicle level. Augmented reality in connection with our DSR-6 models have been used and were used to build space vehicles 9 and 10 faster than we've ever built them. Artificial intelligence assisted tools were used for auto processing of data and test optimization that saved days of TVAC testing. So this has led to our fastest processing of any vehicles to date on Space Vehicle 9. 10 just went through TVAC and got through about the same within a day or two of Space Vehicle 9. So right in that same speed. And these have been really two big key innovations that we've been driving to enhance not just modernizing the signal, but modernizing how we build the satellites and can do them faster and a better cost point. Hopefully, as we continue to drive costs down, we can reinvest then in more mission to both the warfighter and to the civil users. So the one other thing that I just want to share, because if you've never experienced augmented reality, It's fascinating until you actually put the headset on. You can see them in the upper right picture. Until you've put those goggles on and looked through and looked at this, the whole panel layout. You can see it here. There's a black box sticking out of the panel. And until you've looked at it and recognized the exact model, not some translation into a manufacturing work instruction, the actual model that was built, and you built the hardware in, looking through it and saying, oh, okay, I got to put it here, or a harness, like I'm going to route it. Let's see. Okay, I just need to move it up a little bit so it perfectly aligns with the, I'll say the translucent picture. And oh, how far off of the vehicle does it go? Oh, let me just look to the side and I can see how far it holds off the vehicle. So no more measuring tape, validating the place, sticking a clip on, having quality come in, measure it with the tape measure. No, as you can see in this picture, they're just standing right next to them with the goggles on and saying, yep, you did it exactly to the specification. So we think that's something really exciting that's going to be a real game changer as we continue to build these satellites. All right, so let's go to the next chart. Now, mission capability is still the #1 focus in all that we do at Lockheed Martin Space. I mean, our motto is, your mission is our mission. And that is alive and well. We know the mission and the threats that are continually evolving. And we know that the GPS system needs to evolve at the same pace, if not quicker. And we're not so dumb to think that we also don't need alternative methods of PNT. So we need both. The GPS, that's kind of the anchor. I think of it as the power grid. That's the central power, but we need generators and things that could be used in backup or to augment. So we're using model-based systems engineering in concert with digital twin technologies to look at what specific mission capabilities are needed now and in the future. We don't just want to insert technology, right? We want to insert the right technology that provides meaningful improvements to the mission. So with these models and tools, we can perform analysis at all levels of classification and demonstrate real-world scenarios, performance to be confident in the impact these enhancements will make to the warfighter and to the world. Jamming and spoofing have become increased challenges to the precious signal for civil and military users. And with these tools, we can bring data and speed to the decision making. And obviously, these are just idealized videos, because most everything that we do that's realistic, we have to keep on the classified side. But this is just idealistic data to show kind of some of the things that we're doing. Let's see. On chart 7, we kind of jump into kind of the largest things that we're looking at doing from a GPS standpoint. Right now, we know GPS is a key part of our critical national infrastructure. So it's not just about protecting the warfighter, it's protecting this infrastructure. It enables $1 billion a day in economic benefit and is a key enabler to our US military dominance. We need to deliver the modernized GPS 3 and 3F vehicles to orbit. It isn't about replenishment, right? It's about getting these new capabilities operational and available to civil and military end users. Technology is evolving, and we need to continue to on-ramp these advanced capabilities into our production line to ensure active and resilient assured position navigation and timing. So we're utilizing these modeling and simulation methods that I previously described to really evaluate some of the critical areas of focus. And what we're focusing on in the near term are enhancing the civil signals to be more resilient through authentication tools like Chimera, enhancing space service volume to support a variety of orbits and space exploration opportunities. And most importantly, because they're the ones that pay our bills, is the warfighter effect, is the on-orbit reprogrammability and cross-link capability to allow us the flexibility at the speed of change that the military needs. So in summary, I just want to say, I'm proud to be part of a mission and a part of Lockheed Martin Space that's dedicated to bringing PNT and delivering innovative position navigation and timing to the warfighter in the world. This means evolving the current system in an urgent manner to stay ahead of the threats to the critical national infrastructure. But we must first increase the speed of our launch cadence. We need to continue a steady production cadence, and we need to enhance the mission in the most cost-efficient ways across ground, space, and user equipment. If we don't, we are putting the guardians of our freedom in harm's way, because in my mind, we sit back and won't drive the urgency needed to stay ahead of the threats. I love the missions that I've been working in. We need to think even broader about alternative ways of delivering PNT to support all branches of the government and civilian sectors. GPS is the backbone and one of the key parts, but there are a lot more diverse ways that we can add to the resiliency of this precious signal. We must stay ahead of the threat, and I hope that you've learned something about the GPS IIIF and 3 programs and what we're bringing, and I think that's where I'll end here, and I'll open it up for questions.
Thanks very much, Dave. Let's see, to start, we have a question in the chat from Oliver Montenbrook, who's wondering whether the laser reflectors that you described, is it a solid disc or a mesh? And what impact on solar radiation pressure would it have?
Sorry, not the laser reflector, the big dish for the encode.
Yeah. Yes. So the dish on the side is not a mesh. It's a deployable fixed reflector. Super light. They're super cool to see and lift. So solar pressure and the models there, definitely we're working with the ground team, and our team is working with the ground system to make sure we calculate that and understand that. I don't have the details on it, but certainly we're looking at it and taking that into account.
What about us?
All right. Any other questions? We heard some laughing. Somebody had an open mic, but I assume that wasn't, maybe not connected.
So I wonder if you could elaborate a little bit on the search and rescue capabilities. That sounds like a new application for a GPS satellite. How exactly does that work?
Yeah, so right now there are search and rescue antenna and electronics on quite a few different platforms. It's an international community. I always think of it as like the little beacon that if you get thrown out of it, if you crash an airplane and you got your life suit on, the little beacon. But some folks have the beacons that they pull. So there's a international community that does this. So they've designed and built both the electronics and the back end behind it. We're building the antenna to the specs that they need. And what it does is, instead of using PNT signals broadcasted down that triangulate, you send the signal from your user equipment and it triangulates, sends a message to search and rescue, so you don't have to call anybody. So this is an international capability called search and rescue. That's just generically what it's called. And it's that's what we're adding to GPS. Since we're putting all these vehicles up at MEO, we thought it was a great opportunity to increase the precision, to make it so our search and rescue opportunities can be safer and more precise. So we're not the only ones playing in the game, but we're new to joining the team.
Felix has a question. Felix, would you just like to go ahead and ask directly?
Sure. Thank you, Freddie. Thanks a lot for the presentation. I was wondering if there's a chance that satellite metadata, including precise PCO and PCV data, will be provided in order to use GPS for IITRF scale factor determination.
Yeah, so we've been through a process. I think you've probably seen some of that data on the two GPS 2 vehicles, and we're going through a process right now to determine how and if we can release that publicly. But we are going through that process right now. We did some specialized testing to help measure it even more accurately for the first GPS 3 satellite. So that is stuff that we are looking at providing as we can, but we will have to go through the process and make sure it's public releasable.
Thank you.
I saw the question in the chat. So which type of clocks will be used for GPS 3F? We are using the rubidium clocks on GPS 3F. Currently, like I said, first vehicle may not be the same as the last. So if anybody's got some even better clocks out there, bring them our way.
So on one of your last slides, you showed a picture of a little cigarette lighter GPS jammer. I wonder if you could elaborate a little bit about how GPS 3 and the follow-on is more resistant to jamming. And also, if you want to make any comments or not about what's going on with Legato Light Squared and their authorization to do terrestrial broadcasts in the L band that is likely to interfere with GPS.
Yeah, so our near peer, I'll start with that one. So we heard a little bit about that, and we've done some detailed analysis to show what types of effects it might have, and we have sent that information up through our government contacts to try to influence and at least make people aware, make sure we make a decision based in data, right? But at the same time, we always understand that there's going to be challenges going forward, and so we've provided the data, but we're just moving forward, and I can't comment on what effect I think it could have in this forum, but it's something that we provided data to the government for to look at. And then on your other question, so I would say that the biggest thing that we've been able to share, publicly at this point is that the 60 times greater anti-jam capability is the big kicker for improving our success against jamming and spoofing. So the RMP just provides in a much more localized area, right? But that's really centered on the M code side of the signal, right? So on the civil side, we will have the same performance on GPS 3F as we do on GPS 3, which is 8 times more anti-jam capability than the current. So right now it's mostly power, and that's been the biggest benefit that we're getting out of this specific modernization. But as we move forward and look at on-orbit reprogrammability and looking at having more flexibility to the signal, that's where we're driving to look and see how much we need and what's needed to kind of hit the next 10, 15 years versus the next 30 years, right? We're always looking at what do we think is going to be enough.
Looking forward to when cars don't have cigarette lighters in them anymore. Rolf, you have a question?
You mentioned the metadata package in the context of the antenna location. Can you give us a bit more details whether these are only the antenna dimension, the location, or whether we can also get possibly some dimension optical properties? If you say in particular this dish has a big area but low mass, then I'm already a bit worried. So I would also be happy if I understand that you cannot give us the drawings of the satellite, but if we could agree somehow to get a grid model that we get the forces depending on the constellations on Earth satellite, something where we all know that reverse engineering is not possible?
Yeah, so obviously I'd have to work through the government if we're going to release any of that detailed information. So don't have much more information I could share at this point. I don't want to lose my job. So, but that's information that I have to believe that once we get through and have launched these satellites and like start measuring them and understand the details, that we will want to share that with the community, because we know everybody in the community wants as precise. We understand how detailed and precise all the commercial users have been able to leverage, everything about the satellite to get even more precision. And so my guess is the government's not going to be close hold about that, but they will have to get through a certain amount of work to make sure we can share it in a way that the government's comfortable with.
Wow. Yeah, I understand it's very likely a long way through many instances and layers, but at least we would appreciate, I would say really we as the IGS, not just me, would appreciate to get there some information like other systems have done this.
Yeah.
Thank you.
Copy.
Suzanne, would you like to go ahead and ask your question?
Yeah, thank you. Hi, my question is if it is possible to tell if there are any plans for transmitters of very long baseline interferometry as payload.
No plans that I'm aware of, I guess, especially because I don't even totally understand what you're asking. So I guess not.
Yeah, it's another technique for the combination then and reference frame. So thanks.
Okay, copy.
Any other questions?
Rolf has his hand raised.
Oh, okay.
Oh, there we
If
go.
I'm allowed for another question. Was my understanding correct that the SLR reflector is just planned for 2 of the spacecrafts, or is it for the entire series?
The laser retroreflector array.
Yes.
Yeah, that is planned for all the GPS IIIF satellites, so 11 and up. There is discussions about possibly that being one of the swap meet payloads on 9 and 10, so a little bit earlier. But I wouldn't say that that's fully, that's just something that is in discussion.
Cool. Thank you for this.
Yep.
Big applause.
I'm personally excited to see what the difference can be as we use that as well. I'm really intrigued as well. So.
Okay, if there are any more questions, if not, we would like to first of all thank Dave again for a great talk and some insight into GPS III. Hopefully we can meet in person someday and show you around UNAVCO and talk a little more about all this. And so we're going to take this opportunity to ask everyone to turn their Zoom cameras on and do what would normally pass for a group photo at our conferences, and see if we can get a big screenshot with everybody's postage stamp sized face in it.
Dave, if you could turn your screen sharing off.
Oh, right.
There we go.
And also, I'd like to remind you that we have changed the structure of tomorrow's session from originally planned 2 sessions to just one slightly longer morning session, where we'll do all of the working group recommendations and closing remarks. So we should be done by 8:30 or 8:45 Mountain Time. I've lost my UTC clock here. But, so how is our group photo looking? Melissa, are you running that?
So far, so good. I'm trying to get page 2 here. Okay. I think I've gotten everybody. Thank you.
All right, thank you very much. Appreciate the time and the questions. And I wish I could answer them all, but I do have a customer to report to, and it's not normal.
Yeah.
It's not just a private company. So thank you, everybody.
Thanks again, Dave.